In this short explainer, you'll learn about density and its applications in everyday life. To put it simply, density is just how compact a certain substance is. For example, if you were to weigh out a pound of styrofoam compared to a pound of steel, you'd require a much greater amount of styrofoam due to the particles being less compact than the steel. To further understand density, we also require a basic understanding of heat. Hot molecules have more kinetic energy and move faster, so they're naturally further apart. Cold molecules move slower and are naturally closer together. A practical example of this would be the melting of ice into room temperature water. The molecules begin to move faster and spread further apart, so the newly turned liquid begins to spread apart and occupy more area. In this video, I will also demonstrate this principle with an experiment that contains both hot and cold water. Alright everyone, here I have one glass full of hot water, which I've colored orange for the purpose of this experiment, and a glass of cold water. And I'm going to demonstrate the properties of density by showing that these two will not mix. So if I take this hot water one and I put a sheet of glass on top, if I put my hand up top here and I slowly remove this one, so as you can see, the bottom part right here is not quite so yellow as the top part, and they're kind of separated here by this line here. Now if I take my lens and zoom in here, you can truly see the separation between the hot water right there at the top and the cold water right there on the bottom. So these hot water molecules on the top are further apart because the molecules themselves move faster, whereas on the bottom they don't quite move as far and they're closer together, which explains the difference in density here between these two. For some other examples, if you fill a bathtub with hot water and then quickly change the setting to cold to bring down the water temperature, you likely won't feel the overall water temperature change that drastically. Or if it's a hot day outside and you turn on the air conditioning inside your home, you won't feel the entire room's temperature change as soon as you open the door, just a small area right next to it. The hot and cold air have different densities, and thus, when they meet, they don't immediately mix, but rather collide. This is also how you can feel the difference when walking from, say, a cold room to a warm room, and vice versa. In the case of the water experiment that we performed, hot water is a lot less dense than cold water, and in fact, if this process were to continue, the water would eventually solidify into ice. Solids are usually more dense than liquids in most cases. Another useful piece of information is that density can actually be calculated. Density is the object's mass divided by its volume. For example, if you were to have a rock with a volume of 15 cubic meters and a mass of 45 grams, you would simply divide 45 by 15, which would be 3 grams per cubic meter. That would be the object's density, and this can be used for all sorts of applications. According to Stanford research, density is the basis for gold mining, blood separation, strawberry DNA extraction, and even layered towers, which is what you'll see on the screen right now. Density is mostly used to identify pure substances and estimate the composition of many kinds of mixtures. In the case of gold mining, for example, you can compare the density of gold to the density of the other objects and use that to identify the gold and how it stands out to everything else. Finally, understanding the concept of density is vital for other things like loading cargo ships. If a ship is loaded with goods that are too dense, the buoyancy could be thrown off and the ship would sink. Also, if the ship is not dense enough, it could become unstable and capsize. So knowing the density of the actual cargo on board determines how much can be safely loaded and what the minimum amount of cargo would need to be. Changes in density exist everywhere around us, and without them, our world would look completely different. We hope you enjoyed this brief explainer video, and keep in mind, examples of the changes and the differences of density exist every day.